consequence of it being like 18, but you know, it's plus for everywhere in the world. Just to show the individual. Perhaps that's slide 3 people substantially.
Yes, have a new RC.
Yes, we got two things. Two things to hit off for the non public.
Just making sure it's the new version. We'll give it just a few more minutes here because I think we're going to have a pretty light agenda today. And I noticed Ori was still in line at the barista. So we'd like to meet our new area director before we start. For those just joining, we're just going to wait another 2 minutes or so to give a few people a chance to come into the room, and hopefully our area director. We'll give it one final minute before we get started. Okay, it's after 5 past, so let's go ahead and get started. Hopefully, Ori will make his way into the room soon. Welcome everyone to IETF 122 in Bangkok. Apologies for all the remote attendees and presenters that are trying to find a quiet place at 2 a.m. In some time zones. This is the Machine Learning for Audio Coding Working Group. A note please familiarize yourself with the IETF participation policy, especially as regards to declaring any IPR, any intellectual property that you may be aware of in any of your contributions or in any other contributions. So please read through the BCPs listed there and make sure that you're aware of your obligations of disclosure for any IPR that you're aware of. And also note the anti-harassment policies and procedures. Please treat everyone respectfully and professionally. If you feel that you or anyone else is not being treated in such a manner, please contact the Ombuds team, and there's a link to that in the previous slide. They'll be able to work out any issues that you run into. Logistics for participating online or in the room, both use the Meet Echo client. In the room, please use the Meet Echo Lite or on-site tool version. That'll allow you to join the microphone queue, the little raise your hand icon. And it'll also allow you to participate in any calls that we make with the show of hands. Everyone, please keep your audio and video off unless you're being asked to speak at the mic. For remote participants, you can use the full version of the tool. And again, also please to keep your audio and video off unless you're speaking at the mic or presenting. So the agenda is posted here at these URLs. If you have any problem with the Meet Echo tool, there's Meet Echo staff available to help. So our session today, the agenda we'll go through in a second, but first we would like to see if there's a note taker. We need a note taker to proceed. It's very simple. The notepad has already been pre-populated with the agenda, so it's just a matter of recording a few high-level bullets of any decisions or actions from any of the session presentations. Any volunteer for a note taker? It could be in the room or online. Yes, yes. Okay, thank you, Jonathan. And I'm obligated to take notes for AVT Core next hour. Thank you very much, Jonathan. So this is our agenda for today. It's fairly light. We have probably 20 or 30 minutes short of our full time today. One final thing on this Chair Administrivia, we would like to welcome a new area director. We don't see him in the room right now, so maybe we'll do that once he arrives. But just so you'll recognize and know, it's Ori Steele. And we want to give a big thanks to Murray for helping us in the past, although he evaded having to take any of our documents through IESG review. So congratulations to Murray and condolences to Ori. Okay, back to the agenda. So first we're going to go through our work group documents. the Opus extension, the deep redundancy, and then the speech coding enhancements. And then finally, an individual draft that's being proposed for scalable quality extension. Is there any agenda bashing that anyone would like to bring up? And just one note, there was only one change on this agenda. Today we removed one final item that was for the simplification of Opus coding tools. Jean-Marc still intends to progress that, but not in this meeting. Okay, so let's give the floor to Tim. Tim, you'd like me to share the slides, or do you want to do it?
Yeah, if you could, that would be great.
Sure.
All right, so I'm going to talk about the Opus extension draft. Next slide. So the current status of the draft is we published an 03 version with the repeat these extensions proposal that we had discussed at the previous few meetings. Next slide. And so there's been one update in that since that draft was published and since the last meeting. And that was that randomized testing found one case that we had not considered, or specifically I had not considered. So thanks to Jean-Marc for devoting some CPU cycles to that before he merged the code. Basically, the issue is what happens for a frame separator with an explicit increment of 0, right? So we have these frame separators, and you can either have an implicit increment of 1 or an explicit increment coded in a byte, and that byte can have any value, including 0, which is kind of useless. But there was a discrepancy between what I thought I had written in the text and what I actually wrote in the code. So the text says that all of the non-padding extensions seen so far in the current frame get repeated. But the implementation, anytime it saw a frame separator, would update the pointer for where to start repeating extensions to be immediately after that frame separator. So that also happened even if the frame increment was 0. So if you put one of these in there, you're no longer going to repeat extensions that preceded it, even though they're in the same frame. All right, next slide.
Just real quick, Tim, can you clarify something here for us?
Okay, sure.
Was it intended for the frame separator to support an increment of 0?
Basically, yeah, I think the answer is we didn't see a good reason to disallow it. I mean, it basically just acts like padding.
Okay, so it was not envisioned to be an illegal code point. It was
Right.
envisioned to be valid.
Yeah, so like
Okay.
there are illegal values, which is if you try to increment it to a frame that's more frames than you actually have in the packet, right? That's not allowed. But increment it by 0 is basically equivalent to having 2 bytes of padding.
Okay.
And so the current code, even before the repeat these extensions mechanism, would parse that and treat it fine. It just does nothing. But now with the repeat these extensions mechanism, it does something. So if you go to the next slide. So specifically, what it was doing in the initial implementation. So here's basically an example. So it starts off with a long extension with ID 32 and 4 bytes of data. And then it has one of these frame separators with an explicit increment byte that has a value of 0. And then it's followed by a short extension with no payload, and then followed by repeat these extensions. And so because that extra frame separator is in there, only the short extension gets repeated, not the long extension. So this is not the only way to code this, right? Like you could do something very simple. If you look at the next slide, which is you can just code the short extension explicitly in the first frame, then have a normal frame separator that increments the frame number of I1, then code the short extension again, and then repeat. And in this case, that winds up taking the exact same number of bytes. If you had more extensions that were being repeated by the existing repeat these extensions, then you could potentially save a few bytes by adding the extra separator, but the separator itself costs 2 bytes. So it's kind of a, you need to have several of extensions in there before it pays for itself. But even this is not the most efficient way to code this set of extensions. If you go to the next slide. What you actually want to do is just put the short extension first and then repeat it and then put the long extension in there. Then you don't need any frame separators, and you don't even need a length for the long extension because it's now last in the packet. So that cuts your total payload size from 10 bytes down to 7 bytes. Right. So in theory, inserting this frame separator with an increment of 0 could save you some bytes in some special circumstances. But in practice, I think that'd be kind of rare, and it does complicate some things. So the next slide. My proposal was to basically do what I thought I had written in the text to start with, which is that you still always repeat all the extensions from the current frame. So the frame separator with an explicit increment of 0 gets treated just like another form of padding. So you don't update the pointer, and you obviously also do not repeat the separator extension, which fortunately that was something we weren't doing. And so I think this follows the spirit of the existing text, although I'm proposing to add a sentence to make this a bit more explicit. And the implementation was already updated to follow this proposal before it was merged, but it's a one-line change, so it's easy to go either way on this.
Jonathan?
Yeah, Jonathan. So I'm trying to understand this wording. Does this mean that you do repeat frame separators that don't have that increment, and what does that mean?
So if you have a frame separator that has a non-zero increment, then the extensions that follow it are no longer from the same frame as the ones before it. So repeating all the extensions from the current frame will stop at the frame separator.
Okay, I think I see.
I'm sorry, can you clarify that again? I thought I was clear, but Jonathan's question actually muddied it for me. You just said that frame separator with a non-zero increment would mean that all those other frames are repeated? If you had to repeat this extension and a frame separator with a non-zero increment, all of them would be repeated?
So if you have a frame separator with a non-zero increment, followed by some extensions, followed by a repeat these extensions, it will repeat all of the extensions back up to, but not including the frame separator. Right, basically
Okay.
that frame separator marks the start of the current frame. So it marks the start of where you start repeating extensions from.
I would suggest maybe wordsmithing the text a little bit more because it's not 100% clear that the frame separator is not repeated even when the increment is non-zero. Maybe a few sentences instead of a long sentence with ambiguous references. Maybe just another sentence to clarify what you just said, that non-zero increments with a repeat will actually repeat everything but the frame separator itself. Unless there's some other text in the extension itself that says we don't repeat frame separators.
Yeah, I don't have the text memorized, so I'll go look at it. But
Okay.
yeah, there's obviously more text around this, right? But I will do something to see if I can make that a little bit clearer.
Okay.
All right, so that was, I think, the only real discussion point I had for this draft.
You have 2 more slides. You want me to go ahead?
I mean, the next slide is questions, and the last slide's a backup one. But yeah, you can go ahead.
Okay. Any other questions from anyone else? So Jonathan Lennis is asking, are we pretty much done? Are we ready to work group last call this after this clarifying text gets added? Tim, as editor, what are your thoughts about freezing the document now? Is it, do you see any potential changes that could come down when we look at other extensions, or you think it's ready to go?
So I think, like, we never came to a really good conclusion on how the extension numbering should work for long and short extensions. And if we do want to do one of these proposals with, allowing for short extensions with more than a length of 0 or 1, I sort of wasn't happy with my own proposal along those lines. And so I'm not really planning to push that forward. But so basically, I'm not intending to do any more changes beyond this point.
Okay, and so to clarify, the only one open issue that you thought there was, this was back when we thought there was too much complexity in your proposal, and we asked for
yeah, I also thought there was a bit too much complexity in it.
Okay, so you're rescinding that, and you want to leave the text as is.
Yeah, I mean, I think unless there's a compelling use case for these things, I don't think it's worth doing those changes. At least, certainly not as I had originally proposed them.
Okay. Yeah, so we'll ask the list, and we'll make sure that that everybody's okay with that direction. That's the only open issue that you think would possibly bite us? Nothing else?
There's possible, wordsmithing improvements that could be made. I think Mark Harris has given some feedback that, some of the usages of extension versus extension payload versus extension ID is confusing and ambiguous. So probably worth spending some time doing that, but I don't think that'll change the substance of the document any.
Okay. And do you feel that we have enough extensions to cover all the different use cases for needing this extension draft? Do you think just dread and repeat these extensions and what we currently have defined is enough to flesh out the mechanism that we need?
I haven't thought of any other use cases we haven't covered. I don't know, Jean-Marc, are you happy with the state of it?
Yeah, at this point, I really can't think of anything major missing. Like even the repeat these extensions thing we could have done without. It was kind of a close call. We decided to go with it. But yeah, at this point, I have a hard time seeing what new use case would we'd have.
Okay, so for the notes, let's record that after Tim publishes an update for implementing his proposal for the frame separator, repeat these extensions, tweak, and maybe any other editorial fixes that we'll submit this for work group last call. Tim, how much time do you think you'll need to do that update?
Let's call it a month.
Okay, so mid-April.
Yeah, sounds good.
Okay. As soon as you publish that, we'll begin a work group last call mid-April and conclude it well before Madrid. Just so everyone knows, we're well behind on our milestones for this item and all the items actually. So let's try to accelerate and get these closed out. All right.
All right, thank you.
Final slide. Is this just for backup or?
Yeah, it's just in case I wanted to refer to it.
Okay. No questions? All set? Thank you, Tim.
Thank you.
Okay, Jean-Marc, you're up for dread. Would you like me to share the slides or do you want to share?
Yeah, please do share them. Yep.
Should be it.
So I'll be presenting the deep redundancy draft. Next slide, please. So in terms of changes, that's pretty simple. There was nothing that actually changed to the substance of how dread works or how it's implemented or anything. Next slide. In terms of the training procedure, that's something we discussed in the past meetings, how we document that, how we verify things. So I've updated this README document in the, that's the path from the Git repo, where there's some instructions. I've added some scripts that can be used for training. So download data sets, as it says, it basically downloads the entire set that that we're using for dread, and then process speech will extract all of these downloads, concatenate everything, make one huge audio file that can be used. And the rest of the training essentially is not perfectly documented yet, but if you follow all the instructions there, you should be able to get an actual dread model that works. The current one we are using has a few more steps that I haven't yet documented, but at least like if people want to try this, like run all of this, see if anything fails or if I failed at documenting something. And I'll keep adding the rest in there, but there's enough to actually start testing this procedure, basically.
So can you clarify that you're documenting this outside of the spec in this other, is this a repo? Is this a Git repo?
This is the standard Opus repo. I think the text probably should go in the draft. I'm not exactly sure where right now. It's living in that repo, but yeah, probably. I wasn't quite sure how or where to put it in the draft, considering it's how to reproduce, but I'm fine putting it in the draft if you think it's a good idea.
Yeah, for an IETF standard, I think we need to have something in the draft itself, in the final RFC itself, that describes this. A pointer to a repo totally arbitrary revision control and arbitrary archival, I don't think will fly. So if this is not a lot of information, I think it should be put in the actual draft.
No, it's pretty small. It's just that it's not like defining the standard itself, because the training procedure will result every time in different weights, right? But it's the closest we've found so far.
This sounds like an appendix to me.
Fine with that.
Yeah, sort of like how we have test vectors in a lot of specs. This is almost like a test vector, but a bit more involved. This is something that would have been good to have Ori here for. But yeah, let's keep a note of this about the reproducibility and exact specification of what this is. Implementers basically need to be able to do this, right? They need to be able to implement DRED.
No, they don't.
No?
This is only, so implementers will not need to do that, because if every implementer does that, no one's going to be compatible with each other. This is just documenting how we generated the weights to begin with. But once they're generated, the standard is the weights, not this procedure.
Okay, because if implementers do their own, they might get slightly different weights, and even any slight different weight will blow up the conformance.
They will get permutations. They will get all kinds of different things that are equivalent but lead to a completely different format.
And we think we need bit exact results in order for this to perform.
No, this is more than a bit exactness thing. Like, you get models that are about the same, but they are really not the same. Like, if you try to decode something from one with the other, you get complete garbage.
That's what I was saying, is that this would only be for someone to validate something on their own about closeness of their output to your output, but they could never ever use
not even that. Like, they would get similar results, but the output would look very different anyway.
But they could never use their trained model.
No.
Is that correct?
No, they could not. Yeah, that's correct.
Okay. Yeah, so that's even a lesser important appendix.
Yeah.
But I think you do need to specify something in this document that you must absolutely. Do you already say you must absolutely use the exact binary weights that are provided in some way? That we haven't decided exactly how and where we're going to store and reference those, but you do say already that you must use those, and you cannot train your own model. You can train your own model, but you can't use the output.
You can train your own model for fun and to see that it's vaguely similar, but otherwise, yes.
But Jean-Marc, quantizations of the official weights will work just fine, right?
Yes. Yeah. If you quantize the weights, you're good. There's a small table of statistical parameters for entropy coding. Those cannot be changed, and they're actually in the draft. They're not even in the binary. They're in the draft. Those cannot be changed. The weights themselves can be changed, and this is actually something I've got in the upcoming slides where we can discuss like how much we want to standardize, even like the exact weight as opposed to test vector behavior and that sort of thing, or a mix of the two.
Does the current document already describe what you just said? Does it already describe that you must use these exact weights or quantization of them?
It doesn't specify exactly what the threshold is for the weights, because that's not something we've discussed yet. It definitely does say that the weights are sort of the standard thing, or at least I believe I wrote that. But then we need to define like how broad we want things to be. Like, I think we should leave some leeway in terms of weight quantization, because it's not, the weights get trained as float, they get converted to integer 8-bit and with very little loss, and maybe we want to tolerate even further. I don't know exactly how tight we need the spec to be. I'm open to suggestions there.
Are the weights currently FP16 or int8?
Currently, they are int 8, but they come from FP32 training.
Okay, it would be useful, I think, to specify that the original training was done at FP32 and this was quantized down to int8 with little to no quality loss.
Essentially, like, some of the options include like saying, here's the FP32 weights, these are the standard, and we allow deviating by this amount, which covers quantizing to 8-bit, maybe even to 7-bit. I don't know maybe some people would care about that. Or we could say the int 8 bits are the standard, or there's a few variations on there.
The reference code base is using int8, correct?
The reference code base is using int 8 right now.
Then I think it would be useful to provide those, even if you want to also provide the original 32. I think it would be useful to have the exact int8 quantized weights somewhere referenced in the standard.
Or, for example, like, should we even allow implementers to go with like 7 bits if they had like special hardware and they showed that they can get good accuracy anyway? Like, that's the sort of thing I meant as well. I don't have a super strong opinion on that.
Does anyone have any opinions that they want to see something specific documented? Okay, from my perspective, I would like the document to at least specify that the original training was at FP32 and provide a reference to those weights, and also that the reference code base is using int8 quantization of those, and provide a reference to that. I think those two data sets would be very useful for implementers.
Sure.
If you don't have an objection to that, I think that'd be a useful update. And that could close out this modulo, where these are actually archived and referenced from.
Okay, so next slide, please. So now this is for test vectors, which I think are still useful to verify implementations. And my proposal there, and it's not yet implemented, is to essentially provide a set of DREAD payloads using a really simple binary format similar to what we did with Opus Demo. So we have these DREAD payloads, and then we provide the corresponding decoded float features also as binary files. And then, we have a tool that decodes all the DREAD, recreates that float feature file, and we can, compute a sort of distance to see how accurately this is decoded. And we leave some kind of leeway in there. Which also brings in the weight thing, because one option would be to say that quantize your weights however you like as long as you pass the test vectors, or we say you still need to have these weights and pass the test vectors. It's kind of two ways of seeing that. But in all cases, I think we should have this sort of this equivalent to Opus Compare that's going to look at the reference, decode, and the actual implementation and say, yeah, okay, this is close enough. Any comments on that proposal?
And this would be independent of the vocoder used, or would it have any dependency on the vocoder used?
This is independent of the vocoder. It's the features that get sent to the vocoder. And what we really standardize is this part. We want the vocoder to be not fully specified so that anyone could use, a different vocoder.
And where would you get these DRED payloads from?
We would
Where
just
would you
like
get these test
create.
vectors from?
We would just create them. Maybe some created from speech, some created from even like maybe random noise, and making sure that everyone agrees on how they get decoded.
I see a few nods in the room. I think sounds like another appendix.
Yep. Does
Any
anyone
objection?
have like does anyone have like strong opinions on, these tests should be like really loose or really tight in terms of bound?
I think I'd be interested in seeing like what is the quality impact of, say, quantizing to 7 bits on one side, and what is that? What does it look like if the decoder that's quantized to 7 bits decodes it, and how bad does that sound? Because I don't really have a feel for what the sensitivity is to errors at this feature lossy compression stage are.
Yeah, makes sense. Probably a good experiment to try.
Yeah, so I mean, if you saw something like quantizing to 7 bits sounded pretty good, then that would be an argument, I think, for allowing the comparison to be wide enough to encompass that case. If quantizing to 7 bits sounds pretty bad, then that would be an argument against the comparison going that wide, independent of whatever other.
Yeah, I'll run the experiment. My hunch is 7 bits. Either you're not going to notice, or you'll need to listen pretty carefully before you notice the difference.
Along the same lines as Greg's note, I would also consider FP4, since NVIDIA has been championing FP4 recently to double throughput.
Yeah, I don't think we're going to go there.
You think it'll break down in FP4?
Yes. Yes.
It's possible that implementers might, unevenly quantize different parts at different resolutions and get away with some part at FP4, but that's a lot of research to get to that point. So that is an argument for making the comparison be a little sloppy, at least, as long as the audio quality is still good.
That was also why the reason for my original comment about like, do we specify you need to use these weights and pass the test vectors, or use whatever weights you like as long as you pass the test vectors. And there's pros and cons. Like if you make it really lax, like maybe some people like prune some weights or change the architecture, still pass the test vectors, there's a chance that our test vectors aren't perfect, and then some implementations break. On the other hand, if you say you must use these weights, then you're maybe over constraining. That's kind of a trade-off there.
Yeah, I mean, I don't know how much effort you and the working group should spend on studying it, but obviously you could start by zeroing out weights until the test fails, and then see if the result still sounds good, right? There's a myriad ways to try to game the test, but we could guess at a couple of things implementers might do, which is they lower precisions of the weights, or they zero out parts of it. If the results still sound good, I think that's fine, right?
Yeah,
Mark, are you proposing to have this as an informative appendix? These test vectors are just for implementer testing, or are you suggesting that the normative standard only requires testing these decoded features, and you could implement any model and ignore your binary weights completely, and as long as you get the decoded features, you're standard compliant? Is that which of those two are you proposing?
So what I'm saying is definitely it should be must pass test vectors, no matter what. The only thing I'm not sure is whether it should say must use these weights.
Okay,
Or
so you
must
actually want
use
this to be
these
a
weights
normative
plus or
part of the
minus.
standard.
But the test vectors, yes, should be a normative part of the standard, just like they are for Opus. Like if you're not passing the test vectors, you did something wrong.
Okay, and you're still questioning whether or not that should be the only normative part of the standard, and the other model weights are just informative. You can use this model if you want, if you're not smart enough to build your own, but if you are smart enough to do something better and you pass the test vectors, you're good to go.
Yes, that's the, actually now that I'm saying this, I think it's pretty clear that no, we need to say you must use the weights, otherwise someone can just train on the test vectors and they will get a really tiny model that passes all the test vectors perfectly, and it's going to be horrible for everything else. So I kind of answered my own question there. Because the test vectors would end up being a really tiny training set you can very easily overfit to, if that's the only requirement. So I guess we'll need to have the weights thing.
Okay.
So it's going to be both must, like both part of the spec.
Okay, so you'll be doing this this update soon? Or you
Yep.
still are questioning whether or not you have the right vectors and you need help?
I think I can reasonably come up with some vectors there. And considering that you have to use the weights, then the vectors themselves will not be super critical. It's going to be tough to use all the weights and produce something that passes a whole bunch of test vectors, but not others. So I think it shouldn't be too hard there.
Okay, so for the notes, we will add that you're proposing we will add this to the draft, and it will not be an informative appendix. It will be a mandatory normative requirement to pass these vectors, but it won't be sufficient. You still want to have the binary weights, the part of the normative standard as well.
Yep.
Okay.
Next slide, please. So looking at the open questions, there's still the where do we publish the weights, and I guess where do we publish the test vectors now? We're talking about a few megabytes, order of magnitude. If we want the float weights, we're going into the 10-ish megabyte. Otherwise, test vectors maybe also a few megabytes. The weight is about 1. We probably want to provide the encoder weights, even if they're not normative, because most people will not want to train their own encoder. They will just want to reuse what we have. But that gives an idea of the size we're talking about. So that's one of the open questions. There's still the one about how do we define the vocoder and the features. So do we provide a reference vocoder and allow some kind of deviation that can be measured? Do we define some objective metrics on vocoder synthesis? Do we try to invert the vocoder and make sure it matches the features we just decoded, or trying to bypass that entirely and just standardize the features themselves? That's the 4 options I could think of.
Do you have a preferred path here?
Right now, probably the third one is the one I'm thinking is probably the most feasible, but I've not yet tried it. But I wanted to see if anyone again had like strong opinions there.
Okay, I fear we're not going to get enough other implementers to give you useful input on this. I don't know if other people are going to try to use or roll their own vocoders together to give you any input. So if you don't get more input, you think you're going with the third option?
I'll at least be trying that and see if it works. But yeah, that's the plan.
Okay, we have two people in the queue. Benson, go ahead.
Thanks. I'm curious if you'll consider maybe different quality levels. If somebody just needs audio conversation versus somebody who's listening to music or wants high quality music.
There's no music support in Dread. It's all going to be speech. It's all for speech.
Okay, thank you.
So the quality level is, relatively low. Like the highest bit rate is 2 kilobits per second. It's listenable speech, but not high quality. Go ahead, Tim.
Yeah, I was just going to say that the third option there actually looks kind of hard to me, although I'm not sure I have a better proposal, but I basically will be surprised if that works.
We'll need to try it. I guess I'll maybe try a bunch of these and report for the next meeting.
Yeah, I feel like this is where we should be taking advantage of the fact that we actually do have two different vocoder implementations, right?
Yeah, you've got a point there.
Can you clarify that, Tim? Which two vocoders do we have?
So we have the one that we started with that was based on the original LPC net, and then we have the new one, which is based on this Fargan network.
Oh, Fargan? Okay.
I think like that's already probably more diversity than we're going to get from anyone else before this standard is actually finalized.
And Tim, you're thinking it's maybe intractable to generalize those two to have as a black box and match input to output modeling for just those two would be tough.
Well, I'm what I'm trying to say is if you can try to do this for one of them and then see how well the other one fares trying to pass the definition of these features, right? Like you can say, okay, you need the feature analysis on the vocoder output, bus mass input. Well, like you might be able to do that for one of them. Like, can you then just swap in the other one and have that also, have the analysis of those features also work? And I guess in theory, if it's really generating a speech signal that has those specific features, like you should be able to get kind of close. Like I kind of see what Jean-Marc is saying here, but I feel like that's going to be hard to define what match means, but we'll find out, I guess.
Yeah, we'll see. I'll try and come up with something anyway. I was exposing the options in case someone had like opinions for or against some of them.
Is there any existing body of work on vocoder, a quality assessment or something, vocoder performance assessment?
So in this case, it is not so much what I'm trying to standardize here is not so much the quality of the vocoder, because honestly, I would like people to be able to even use like shitty vocoders if they want to. The main thing I want to make sure in some sense is to standardize the features, like making sure that we don't end up in a case where one vocoder produces something and another one produces something else. which means that then people start encoding different features. So this, to some extent, it's almost more like standardizing the features and standardizing the vocoder. But I think it's nicer to do it on the decode side than on the encode side, which is why it becomes the vocoder.
This seems like a fairly significant open issue in the draft. What is your thought on timeline to decide this and document and close this?
Can't guarantee, but I'm hoping to have this by the next IETF. Or at
First,
least have
let me back up
something
and let me ask, is everyone clear that we need to specify something like this, that we can't leave the vocoder unspecified?
Well, we could have the vocoder unspecified, but the features need to somehow be specified. Otherwise, what could happen is someone computes different features or computes them completely differently, and they train a different vocoder, and then the two implementations are incompatible, or like pitch goes one way for one and the other way for the other one, right?
Okay, we have Ahmed in the queue. Go ahead.
Hey, Jean-Marc. So one question regarding this standardization of features. Could it happen that maybe due to these improvements in neural networks and machine learning that some new types of features can come up and then they can achieve somehow better quality? Do you expect this to happen due to improvements on feature learning and representation learning, or that's hard to be done?
I mean, we can come up with a better encoding scheme or better features, but at this point we need to standardize things. Otherwise, you could use the newest thing, but it's not going to be compatible. So we're trying to settle on something that we can phrase, even if someday someone comes up with something a bit better. But that's the only way to ensure interoperability.
I see. Fair enough. Thanks.
But yeah, the sort of extreme and kind of silly example I was going to say is, if you take the pitch parameter and you flip it, right? All of the the decoder will flip it to, like you flipped it on the encoder, it's going to be flipped on the decoder. And then your vocoder is trained to have it flipped. So, suddenly like male voices sound like female and the other way around. And the intonation is like inverted.
Okay.
So you need to somehow define these features, either in terms of what the features mean or what the vocoder is vaguely supposed to do with them.
Okay, and just to confirm my understanding, in case of standardizing these kind of features, then the possibility to improve vocoder will be through better data and architectures and training losses, so to say. But features should be fixed.
Correct.
All right.
Exactly. Yes.
Yeah, I see. Cool. Thanks.
Yeah, so that's definitely something I'll be looking at. And then the last question is basically like, what else do we need to finish? Like, is there anything I missed in there? Other open questions or things that need to be done?
So just to make the work group aware of offline conversation Jean-Marc and I had, one of the questions that I raised was about the actual audio quality of the output of DREAD. Here we're talking about, standardizing rather arbitrary things, latent features or vocoder features, and it's not clear how they map directly to speech quality. And so the question was whether or not we need any kind of evaluation of the speech quality that's output by DREAD. And I'll let Jean-Marc answer what he thought about that.
Yeah, so I think If people have resources to do a listening test, like I think it may be useful to take the final weights and run some kind of testing similar to what we did in the past to sort of verify that, you know, we're still improving quality, a bit like we did with Opus, but that's again dependent on any resources to do subjective testing.
Okay, if anyone in the work group has any interest in that, I think that would be welcome because I think it would pull in more audio expertise. You know, the things that we're looking at here in the draft are pretty narrow. You know, if you're not working directly on the DREAD model, you know, you obviously would have no clue about what the latent feature vectors are. And if you're not working directly on the vocoder, again, you may not have good input on what the feature matching from input to output should be on that. But speech quality is a relatively well-established area that almost any audio researcher can contribute to. And so analyzing the final DREAD quality may be useful if people have cycles to do that. Okay, then an open question, is there anything else? Has anyone read this and still felt something was missing, something was unspecified? Okay, hearing nothing. I think Jean-Marc, if you don't get any other input from anyone else, then use your discretion to go with option 3 there, or heed Tim's warning about not being able to do that successfully and consider one of the other options, and try your best to get an update before the next meeting so that we can try to progress this towards working group last call. We believe that's the only, aside from the issue of where to reference the weights, where to reference the final binaries, this seems to be the only major outstanding work item left to close out the draft.
That's good.
Okay. Thank you. And don't go away yet, because we will just very quickly just jump back up to the agenda here. Yeah, so speech coding enhancements. Unfortunately, Jan had a conflict with this meeting. He's unable to attend even remotely. And so we do not have a presentation about the updates there. But what he told the chairs before the meeting was that there haven't been any substantive changes. So this first version of the working group document is a direct mirror of the last version of his individual draft. So there haven't been any changes in the actual text. Now, having said that, I believe Jean-Marc may even mention that there still has been some work ongoing that may not be reflected in the current working group draft. So hopefully we'll get an update from Jan either on the list shortly or at the next meeting about those updates. So we should see a No1 that has those updates. Okay, so then our final item is the scalable quality extension. And Jean-Marc, you want me to share again?
Yep, please.
Okay.
So this is an update on my previous presentation about scalable quality extensions for Opus Celt. There is now an actual draft. Listed here, draft value Opus scalable quality extension. Version 0.0 was submitted about 2 months ago. Version 0.1 was submitted, when the Pew reopened during this meeting. So you might have not seen it. That's fine. I'll just go over it quickly. Next slide, please. So again, this what this proposal means is we're trying to lift some of the limits of the Opus bit stream, trying to support more than about 8 bits of depth in each band, support for wider than 20 kilohertz bandwidth, support all the way up to about 500 kilobits per second per channel. Right now, the maximum is around 250. And we want to do all of that while maintaining compatibility with RFC 6716. Next slide, please. So this is how it's implemented in terms of payload. So we use the extension mechanism as in Tim's draft. We use a long extension ID, right now 124, which is an experimental ID, eventually probably ID 33. The payload is entirely entropy coded. And there's a high level list of what we code in there. So we start with a bunch of flags signaling whether we're coding at 96 kilohertz or just 48. That's 1 bit intensity stereo, dual stereo, whether the coarse energy is intra or not. And then we go with the actual core bits there. So the coarse energy for the high bands. So high bands start at 20 kilohertz. Then we code a bit allocation. We code fine energy for low bands, so extra bits for the fine energy. Those could only go up to 8 bits in the original spec. So while coding those, we add extra bits in the payload that are to be decoded together. The same thing goes for PVQ, where we code refinement bits in the extension payload. This is followed by fine energy for the high bands, and then PVQ in a new cubic codebook just for the high bands again. So that's the content that we code with that extension. Next slide, please. So this is high level of how this works. In terms of the PVQ refinement, we in the original spec, we use this codebook size K, which defines sort of the sum of the absolute values in the vector. And we upscale this K value by a factor U that's equal to 2 to the number of bits minus 1. So we use an odd number there. And the way this is done, we code the vector Y in the normal way using the normal codebook K that ends up in the standard Opus bit stream. And then we find another code vector using U times K. So we find this new code vector Z, and we compute the difference between Z and U times Y. And then, so we get this refinement signal, and we put that refinement in the extension payload. So if you don't have the extension, you still can decode Y, do the normal decoding. If you have the extension, you can get the refinement and get a better, a more accurate codebook representation. So that's for PVQ. Next slide, please. There's also some scalar parameters. I mentioned the fine energy, and there's angles that are used when we split bands in two or when we do stereo coding. So both of these are scalar parameters. For the fine energy, we add again a refinement of 2 to the power of B, where B is the bit depth. And we use these extra fine energy resolution instead of what is called the final energy in the Opus specification. So if you use this extension, you discard these few bits that we coded just for simplicity's sake, and it doesn't matter very much. And this refinement is only used for low bands, because for high bands, we can use any number of bits we like. We're not restricted to 8. because we're not bound by the bit stream there. The angles get a similar refinement. It's an odd value to the b-1. This is due to the fact that for angles we want to have the code vectors that perfectly line up with the original values, but otherwise the principle is the same. Next slide, please. Now we also need to define these extra bands. Opus only goes all the way up to 20K. So if we want to go above that, we need new bands. And because once you've reached that point, psychoacoustic is sort of out the window. We just use 2 kilohertz bands all over from 20 to 48. That means we've got 2 extra bands if we want to cover 20 to 24, or 14 extra bands if we want to cover 20 to 48. We code the new bands almost like the regular ones, with the exception that when we get to higher than 2 bits of depth, we define a new cubic codebook, which is basically, the original PVQ is kind of a reflected pyramid that we project onto a sphere. In this case, it's an empty cubic shell that we project. And the main reason we do that is the search is a lot simpler, and the encoding is also very cheap, even at high bit rate. And again, for these high bands, we're not bound by compatibility, so we just use that codebook. Next slide, please.
Just one quick question as individual here. Are you doing just linear 2 kilohertz wide bands all the way up for simplicity, or it seems kind of odd that you wouldn't have larger bands as you go up higher? Is there really a need to differentiate between 46 to 48 and 44 to 46, or do you think that's just it's simpler to have this linear range of bands?
Yeah, like mostly the reasoning for the wider bands is all the psychoacoustic stuff, but once you get to these frequencies, there's no psychoacoustic anymore. And so it simplifies a bunch of things. And also we're talking about very high bit rates, so you don't need to really optimize and save like 2 bits by tweaking the bandwidth. It doesn't matter at this point. Like we're way beyond the bit rates where it really matters.
So you don't think it would be a simplification to have fewer, bigger bands as you go higher? You think it's simpler to just have smaller linear bands all the way up?
Yeah, it's easier to deal with. I actually started with wider bands, and it was a pain to deal with. So.
Okay.
So in terms of status, there is running code. It's in the latest is EXP QXT24 in the Opus repo. We tested with the audio precision software. It achieves -115 dB THD plus noise at 480 kilobits per channel across the whole range of frequencies. Some frequencies it's even lower than that in terms of THD plus noise. There's a complete implementation both in fixed point and in floating point, and the two we verified they're interoperable, and they're able to also produce this -115 dB. So I guess some of the open questions at this point are how we exactly standardize this. I suspect there's not going to be much choice but to have some amount of source code like the original spec, because it's a modification of the original spec. But exactly how we do it, still we can discuss that, and also like what we do about test vectors and how wide we want to make the margins there.
Jonathan Lennox, question: is the encoding of the base opus unchanged, or does this? I mean, is the unenhanced part of the output identical to what you'd get with downsampling this and running it on the original Elpis encoder, or are there changes? Because if there are changes, we need to validate those as well.
The base layer has exactly the same definition. If you run the original test vectors through this, they will produce exactly the same thing.
Okay, but I guess my point is I want to make sure that the output quality of something that was done at high bit rate, but then output by an old decoder won't sound bad. Have you done testings on those?
Yeah,
Basically,
if you take essentially, if you remove this extension payload, the new and old decoder will decode exactly the same thing. It's going to pass the test vectors.
Yes. So what I'm saying is they'll decode to the same thing, but have you done quality assessments of that what comes out sounds good if you're starting from a high frequency range, high bit depth? Basically make sure it doesn't make stupid decisions for the base.
You're talking about the encoder? Are you talking about the
encoder?
Or the
encoder.
The encoder is completely unspecified. I mean, in practice, it definitely works. It does the same thing it did, but the encoder was already unspecified.
We're just specifying the decoder here, right? Okay, yeah. Which I think is different than the original. I'm not sure. Did we specify the encoder for original Opus?
Nope.
No.
Okay.
Jean-Marc, the fact that this does at high bit rates achieve like a really good THD plus N result, does that perhaps make it easier to specify a comparison mechanism based on the output?
Yes, I think so. Like we'll probably be able to just use like standard mean squared difference or something like that. We won't need to be as fancy as we had to be with Opus Compare, I think. And especially like if you look at the fixed point implementation with that, even if you don't decode any extensions, if you compare the floating point and the fixed point decoder, they match within like really, really close, which was not the case in the original specification, which is why we left Opus Compare like much looser, essentially. This will need to be pretty tight. So yeah, that makes it easier.
So what you're telling me is that you don't need me to do a second implementation with bugs in it this time.
You're off the hook, Tim.
Have a go if you like.
Okay, so to remind him, yeah, go ahead, John.
Yeah, and so I was also going to ask, like, I don't know how we can proceed, but if people think this should be adopted by the working group, or how we should go about this.
Yeah, that's what I was going to bring up. So to remind everyone, this is for our charter item about enhancing Celt-coded audio, Opus Celt-coded audio. And so we don't have a draft yet for that. And seeing as how we're well past that milestone, I would like to try to get something going as fast as we can. If there are no objections to this work, I'd like to start a working group adoption call on the list after the meeting. We asked about interest at the last meeting, and there was general nods about interest. We asked about objections. There weren't any. We didn't have an actual draft. Now we have an actual draft. And it seems kind of early to be asking for adoption of a 0-0 draft, but not hearing any objections, we intend to do that on the list pretty soon. So please read the draft if you haven't already. Please comment on whether you think this is an appropriate starting point, whether you think the work itself is interesting and should be in this working group. And hearing no objections, we'd like to go ahead with adopting this pretty soon before the next meeting.
Thanks.
Jonathan?
Yeah, I just had one question, something I noticed on the slides earlier, which is not an objection anyway. I noticed you had a joint stereo flag in the extension. Does that mean the stereo state of the extended data can be different from that of the baseband? I mean, could you do a mono bass and a stereo extension, for instance? Would that be useful?
It's not about, this flag is not about being mono or stereo. The whole thing is mono or stereo, but the channel coupling can be different in the high bands from the baseband.
Okay. Because I assume because often the low frequencies are more coupled than the high frequencies or something?
I don't know exactly what this content looks like. It just seemed like it's one bit we might need it.
Okay. But it's not
super critical.
Okay, cool.
Okay, anything else about this draft? All right, hearing nothing. That brings us to the end of our agenda. Any other business people want to bring up? Jonathan, I assume you're just lingering in the queue. Didn't mean to be. Okay. All right. Okay, well, thank you, everyone. Please review the documents that we have. We'll be doing that adoption call on the list pretty soon before Madrid. And enjoy the rest of Bangkok. Cheers.
Thanks all.
Thanks.
you,
Have a
Greg.
good one. Bye.
Thanks.
I believe we're in the same room here for ABT. So we'll just switch places and I'll take notes. I think I got the short end of the stick on this deal. I expect there's going to be quite a few more comments.
Yeah.
on ABT.
He volunteered, he said he was backing up because
Yeah, I'll back up.
he didn't know all the background of everything, so.
Happy to. It is absolutely freezing in this corner. I don't know if it's the whole room, but this corner is like an ice box. You probably feel it back here before you come back after the break. So Magnus, do you see any non-technical problems with doing this high bandwidth extension work? This is in the realm of entertainment codecs, which is a IPR heavy contentious space.
I have no idea. I mean, you know what? I don't know. I assume that there's, if you get into high fidelity codecs, yeah, you are going to run into various IPR.
Those are heavily licensed technologies.
Yeah. My only audio related IPR has expired last year, so.
That means we can use it. What was it? Was it high resolution? Okay, Drag can use it.
Yes, like it's for if you use two different codecs that you tightly integrate into one decoder space.
Into one decoder.
One decoder taking two different standards and merging them into one. So this is from my master thesis. I did LPC the download codec to GSM EFR. I never got it to. Objective measurements was much better. The subjective measurements was
Would
the
Silk
lack of polishing.
would Silk LRR frames qualify? Would it read on that?
Yeah. So as I said, it's expired.
Okay, we got 5 minutes before the snacks are out.
There's people put them out early. This is not one of the places where they carefully guard the snacks.
Yeah, this meeting is like food heavy. They had like full on food almost every break.
Yeah. I mean, I went to the food culture, but B, I'm pretty sure that it's also cheap. Food is cheaper here than many places, and we have a fixed budget for how much we spend on food. So I think we're like spending like high standards. We're like, spending lavishly on. That's give us the best food.
Yeah, relative to London or
Yeah, or wherever. Exactly.
yeah, I think been able to eat dinner, no snacks. I'm too full.